This is that Packard Bell chassis that I got from the Hall of Vintage TVs, and I figured I would kind of clean it up a little bit and see if I could get it to work. The power cord is completely shot, and it needs a good blow job and lubrication. It'd be interesting to see if I could get it to work. It's obvious this has been replaced. You can see the it's only got one electrolytic in it, I believe, because it has a field coil speaker. So I twisted a new power cord in here and cleaned it up. I don't see all that much it could really go wrong, except these wax IF transformer right there. Let's plug it in and see what happens. The worst that can happen is it can explode and spray flames all over the place, right? I hear humming from the speaker. Grab an antenna. Pretty cool. Huh. Weird. Guess maybe if this guy was shorted or something. Or maybe this one here. Maybe if that one is shorted. So this is RF, oscillator, IF, audio output rectifier. Or is this oscillator, IF? No, so this would have to be the detector. This sucker's old, so I'm not, and there's no kind of identifying anything on here. So I guess I could just kind of start looking through the Bateman's books until I find something close. It'd be neat to see it work again, just to see it work. I wonder if this could be bad, because it looks like it's been replaced before, and keep in mind this radio sat outside for probably, there's a lot of, actually that looks kind of a hack job repair too, but if you look at this, that looks like it's been replaced. So what is this, a 10K brown, gray, orange, 183, so like 0.018, that sound right? Okay, I believe I finally figured out what this Packard bell is, and it's a Model 35, and it's quite the weirdest radio I think I've ever seen. I don't understand this design at all. There's been some added components, and I've been tracing this out, and this right here and this are the tuning capacitor. So this is the antenna and this is the oscillator frequency, and these are the IF. And someone added, they cut this line right here and they added this mic in. Actually, there's been a bunch of modifications to this radio. They added this in, which I broke off on accident. This is the IF transformer. And these trimmers down here, there's a trimmer there, a trimmer there. Those are not on here. Those should usually be paralleled around here and around here. Those are like the screws on the top of most radios. So I think what I'm going to do is, this is a 460 IF. I think what I'm going to do is I'm going to delete that mica, and I'm going to inject 460 kilohertz in here, and I'm going to try and peak these two, because this thing, I mean, it's super heterodyne, but it's almost like some type of regenerative type deal, because I mean, check this out. Okay, this is the antenna right here. This is the volume control. The volume control is connected to the antenna, and then it's connected back here to the, I guess that's the cathode of the IF amp. So some kind of almost regenerative super heterodyne deal. This is the tone control. Here it's just a shunt from the plate, and I got to figure out what this 50M means. Is that 50K or is that 50 megs? I don't think it's 50 megs, but a lot of these are, I mean, like, what's that, 0.5 W? 0.5 ohms? So is that 500 ohms, 500K? What is that? And then here we have a 5,000. Here we have, and then here we have a 25 meg. And of course these resistors don't have any kind of color codes on them at all. They're just like this one, red and green. Well, green is 5 and red is 2. I mean, I don't get it. And this one, green and yellow. And how about this one, black with a yellow dot, black with a yellow dot. So, I don't know. I don't get it. Or maybe that's supposed to be green, black, brown. I don't know. Okay, it appears that M is like K. So this is a 25K. This is a 50K. These were like 5K. So what's very interesting is these things all measure within 1 or 2% of their rated value. These weird two-color resistors, they all measure dead on, so I'm not going to worry about them at all. I'd really like to get this radio to work. I'm hell-bent on it at this point. I don't care what it takes. I want to see it work, just because it's so weird. Yeah, I was thinking one reason maybe someone put this capacitor in here was these plates were touching. And sure enough, okay, let me get the magnifying glass out. I got it. It was this last one on the end here. This one's always shorted, so I need to check. I need to disconnect this and check this variable cap. And then I'm going to disconnect this and get rid of this and put it back to original. And I'm going to do an IF alignment on it using the generator. Okay, I disconnected that lead and verified that this capacitor plates were not shorting. And I removed the mica cap from there, which is not shown on the schematic. And it's acting pretty much the same. It's pretty much a noisemaker. So what I'm going to do is I'm going to try and do an IF alignment on this. So let me figure out how I can. The IF transformer is right here, and it's a variable trimmer capacitor, not fixed capacitor, variable core. It's old style. Okay, here's what I'm going to try. I'm going to try winding up a coil wire and sticking it right there, because I'm not sure how to couple into this. So we'll just put that kind of right there. Let's see. AM modulation, 1000 hertz. Crank this up. Let's go down to, so this is 460 kilohertz. So let's go to 460 and start to crank the power up. And absolutely nothing. That's a grip of power too. That's plus 20 dB. It's like close to a watt, something like that. Really, so there's nothing getting through the IF. Huh. I could try clipping onto the antenna, I guess. I'm isolated. Boy, absolutely. Oh. Really? Is this thing that out of whack or what? This radio is a trip. This radio is just... It's weird. It sounds like there's some activity, but... Alright, I ohmed out all of these coils. And everything seems good. I checked the tubes. There aren't really any capacitors in here to speak of. So now I'm injecting into here, this is the IF amp, and this would be the grid of the IF amp, which goes through this kind of weird open, this isn't connected to anything, it's a hollow core thing wrapped around a little form, IF transformer. So I'm going into there. And it seems like the peak of that thing is about pretty wide. It's about 491, 490. The sensitivity is decent. That's at -30. That's actually this right here. There's no core. There's nothing to adjust there. There's no capacitors associated with it. I guess it's supposed to kind of be tuned at 460 kilohertz. And this is the front end IF transformer. And this is the oscillator coil right here. Huh. So obviously the oscillator is not running. Sometimes these simple circuits are the hardest thing to get working. The oscillator with the condenser all the way open, the tuning cap is running at 657 kilohertz. It's kind of low. Here's what it looks like as I tune across the band. That's all the way open. I don't know, this thing just makes a good noise maker. I tried changing some of these caps, it made no difference. I checked all the resistors, made no difference. I've adjusted these caps every which way possible. I'm almost wondering if maybe this thing is jacked up, it's got some corrosion or something in it, and it's not. It ohms out okay, but it's not saying that the caps are, although they seem to work. I don't know, I'm baffled. Check the electrolytic setup. That I put new that didn't change anything. So I'm really stumped. One thing that seems kind of excessive to me is the drop across the field coil on the speaker. It's 135 volts. When I pull the audio output tube out, it goes down to about 30 volts, and the B plus goes from 130 up to about 320. So I'm wondering if maybe this tube, I checked the voltages on it, they're all good. I'm wondering if maybe this output tube is bad. Even with the voltage at 330, the oscillator is still not running right. It doesn't look like it on the scope. Still running way too slow. I'm expecting it, I guess, to run at 450 or 460 kilocycles above the frequency I want to tune in, which it's not doing. It's running way slow. So I'm stumped on this one. I got to go to the electronics store anyway. There is an electrolytic missing out of here. I got one bridged in. I'll grab one when I get to the electronics store, and I ruined this paper cap. I'll grab one, a .001 for there, and I'll also test. I'll disconnect the tuning capacitor, and I'll test it with the capacitor checker. I don't know if anyone has any ideas on this noise machine. Let me know. I wanted to add this on. I was looking at what I said earlier. I do understand how this volume control works. Basically, you have this is the B plus line through a 25K resistor going to here to the volume control, which comes up to the cathode of the IF tube. So as you adjust the volume up, it reduces the voltage on the tube, turning it on. As you adjust the volume down, the voltage increases on the cathode, cutting the tube off. And at the same time you're cutting the tube off, you're shunting the antenna to ground. So I do understand this now. I just had to look at it. It's confusing the way they have these tubes, diagrammed on here. Also, there's no voltages anywhere, but I did find this. I totally missed this last night. The alignment of the receiver is as follows: set the signal generator to 460, the IF peak and the volume control full onset variable condenser with plates fully meshed. I did all this. Adjust IF trimmers directly beneath the variable condenser for maximum output. Then tune the signal generator to 1700 and adjust the trimmer on the variable condenser for maximum output. Well, this never had that. Somebody added it. The adjustments for 1000 and 600 will have to be made by bending the outside rotor plate to the variable condenser for maximum signal. Okay, so this is part one of who knows how many.